So in the previous video we were having a small discussion about the data types which we use in case of C programming language, and we discussed about the data type which is the data type integer. Now in this video we'll discuss about the data type which is character as a data type. So to represent the character we use the keyword which is char, C-H-A-R, char. So first of all we need to discuss about what is the size of character as a data type. Number two, how many symbols do we represent using the character data types? Symbols. Number three, what are the ASCII values of those symbols? Okay. And number four, we'll be discussing about what are the different types of character as a data type we can use. For example, there are signed character as a data type and there are unsigned characters as a data type. And number four is how to find the ASCII values. How to find the ASCII values for character as a data type. So initially we'll discuss about the size of character as a data type. So size of character is of 1 byte in case of C++ and C programming language. 1 byte means there are 8 bits. There are 8 bits in a character. And with the help of these 8 bits, how many symbols you can represent? With the help of these 8 bits, you can represent 2 raised to power 8 symbols, right? So if this 1 byte is of unsigned, if this 1 byte is unsigned, in that case the minimum value will be 0 and the maximum value will be 2 raised to power 8 minus 1. Now if it is a signed character, in that case the minimum value will be taking is minus 127 to plus 127. Okay, that we will see why it is minus 127 and why it is plus 127. So initially let us discuss about what is the size of this character as a data type. So here I'm going to write a simple function, that is cout, and I'm going to print size of character. Now if I'm going to execute this one, build and run, you can see the size of character is of 1 byte. It is representing the value which is 1 byte only. Okay, now I can take a character variable. I can take a variable which is character A is equal to capital A. So that means this capital A is stored inside this character A, and to print the value of A I can just print A, and then if you build, so it is just going to print the value which is capital A, because capital A is stored inside this character. But what is the ASCII value of this A? So to print the ASCII value we can do two things. Number one, either we can use the cout function to print the ASCII value, cout integer value of this character A, okay, or what we can do is we can also use a printf statement, that is printf, and we are going to use printf with %d comma A. So these are the two values how we can print the ASCII value of this character A. So I'm going to build and run. Now you can see it is printing the ASCII value of capital A which is equal to 65. Now I think most of you already know what is the ASCII values or how we represent the ASCII values. There are some common ASCII values which you should know. Number one is, if we use the ASCII value 65, then 65 is used for capital A, 66 is used for capital B, 67 is used for capital C. In the same way 90 is used for capital Z. After this 97 is used for small a, 98 is used for small b, 99 is used for small c, up to so on 122 is used for small z. That is why capital A and small a, they are not the same, because they are having two different ASCII values. I think this is clear. Okay, now what if we pass ASCII value here, and by passing the ASCII value here can we print this character? Let us see. Instead of passing capital A, if I pass 65, then what happens? Then I'm going to execute, I'm going to go to build, and I'm going to go to build and run. Now this 65 is an ASCII value of capital A. That is why in the first line here, in this case it printed the value which is equal to capital A. But In the next two cases, in this case and in this case, we are deliberately trying to print the ASCII values. So instead of this, if I write just here %C, that means I'm going to print the character. Now if I execute the program, I'm going to go to build and run. Now this way it is going to print capital A, that means I'm printing a character symbol, I'm not printing the ASCII value. So this is how you can represent this character. Now what if we try to store the value which is greater than the limit of this character? For example, I told you that there's a signed character and there's an unsigned character. The signed character, the maximum value is 127. Okay, so what if we try to store 127 in this one, and let us see what is the equivalent ASCII symbol for 127. So build and run. Now you can see the equivalent ASCII symbol is like this, a question mark symbol. Now instead of 127, what if we store 128? Now for 128, it is going to take some symbol which is this symbol C. Okay, now if we print 129, it is taking a symbol which is U. And instead of this, now if I am printing minus 128, now in that case again it is printing the same symbol. And if I am trying to print minus 129, in that case it will print the same symbol, I guess. Yes, it is printing the question mark sign, the same symbol. Why? Because we are using signed bit representation for this one. Okay, that is why it is repeating for 128 as 127 as well as minus 129, because they are having the similar signed bit representations. Okay, now when we discussed about the integer as a data type, now in case of integer as a data type, integer representing the 2's complement representation, integer uses 2's complement representations to represent the negative numbers. But in case of signed characters, then it uses it does not use 2's complement representation, it uses signed bit representation. But there's something called as unsigned characters also. Unsigned characters, that means they are not having negative signs. Okay, so I know what is, now you know what is the size and what are the symbols we use. Okay, and what are the ASCII values? So you can discuss about the ASCII values. There's a table. If you search on Google the ASCII values and the equivalent symbols for C++, then you can easily find out the ASCII values even for C++ as well as for the C language. Okay, I hope this is clear and you know how to find the ASCII values. So this is about the character as a data type. I think you already have some experience related to the character as a data type. So the next type of data type which we'll be using is the floating point data type, float. And the size of float is of 4 bytes. Okay, there are few data types which we use. Float is there, then there's something called as double is there, and the size of double is of 8 bytes. Okay, I hope we know what is a float as a data type and what is a double as a data type. Now let me give a very simple example, which is by which you can easily clear what is happening here. If I'm taking float A is equal to 3.36 some value. Now if A equal to 3.36, then print high, or you can say just cout high, else cout by. Okay, now if I'm trying to execute this one, build and run, now you can see it is printing by, it is not printing high. Why is that case? Even if I'm storing 3.36 in the variable A and I'm trying to print if A is equal to 3.36, then it should print high, but it is not printing high, it is printing by. Actually the case is when we take this floating point representation, now any point number by default is a double number. So C and C++, they supports automatic type conversion. Automatic type conversion. So what is this automatic type conversion? Is that means this, even if this is by default a double variable, but because we are trying to store this variable into a floating point number, so you can easily, you are going to convert this value to a float number. Okay, now here what is happening is, here we are comparing this A, where A is a float variable, and here we are comparing 3.36, which is a double variable. So the size of float is 4 bytes and the size of double is 8 bytes. So that is why these two values are not actually equivalent, because the way these values are stored is different. So you can see these two values are not same. That is why it is not printing high, it is printing by. Now what if instead of saying this one, instead of storing 3.36, we stored 3.36f. Why I'm saying 3.36f? Because 3.36 is a double number. But if I concatenate 3.36 with f, this f is specifying that this 3.36 is a floating point number. It is a float number. That is why if I am writing 3.36f here, so it is going to give a float number, and that float number we can use to compare the values. Okay, so for example, instead of this, if I'm writing here 3.36f, now after writing 3.36f, now what is happening? This number is a float number, as well as this variable is also a float variable. Now because both of them are float variables and their values can be compared with each other, hence we are going to print high. So I'm just going to go to build and I'm trying to run the program, and you can see here it is printing high now because these two values are same. But what if we remove this f? If we remove this variable f, this symbol f, then this is a double number. In that case, this becomes, instead of float, this becomes a double number, and that becomes a float number. Double number and float number, they are not the same, hence it should print by. Now if I execute this one, build and run, it should print by. So this is the difference. This is about the floating point numbers. Okay, now there's a range for the floating point numbers that you can easily find out, and you can easily find out what is the size of a floating point number. To represent the size of a floating point number, let me write a program. What is the size? That, as I told you, size of the float variable is of 4 bytes. So I'm just going to write cout size of float, and you can see size of float. If I am going to build and run the program, the size of float. Okay, so I have to print size of float. So I'm going to go to build and run. So the size of float is of 4 bytes here. Okay, now you understand what is the size of floating point variable. Now you understand what is the size of double variable. A part of this, there are more data types which we generally use. There is a data type which is called as boolean, and this boolean data type is represented by bool. A part of this, we can also have some other data types, like we know what is an integer, but we can use short int, and as well as we can use long int, as well as we can also use long int. Okay, so let me wrap it up. We can have short int, long int, and as well as we can have long int. Okay, so you can, these are the types which you can use before a variable, so that you can specify or you can increase the size according to the requirement. So I'm going to write size of integer, the first line. So here I'm going to write the size of integer variable. Let me have it. Integer variable is size of integer. Okay, and I'm going to change the line, that is NL. Then I'm going to use the same command, and this time I'm going to write size of short integer variable. Short integer variable is size of short int. Then size of long int, so size of long integer variable, and then I'm going to write size of long integer variable, and here I'm also going to write long int. Now let us try to execute the program. I'm going to go to build and run. Now you can see size of short integer variable is 4, size of short int is 2, size of long int is 4, and size of long int is 8. Okay, so this is the size which are given. I'm just again going to build and run. So size of integer is 4, short int is 2, long int is 4, and long int is 8. Do we have a variable which is long int? So I'm just going to make a simple change here, and this time I'm going to write 3 times long int. Do we have a long int variable? So I'm going to write long int, build and run, and you can see there's an error here because it is saying that we do not have long int because it is a very too long variable for GCC. And when you can see here in the logs, so you can see error long is too long for GCC, so which is one error, zero warning. So this is not an warning, this is a typical error which is saying this long int is not available for the use. Okay, so hence we cannot use long int. I hope this is clear. Now in the same way we can have characters. Can we have short character and long character? Let us try. So we can use cout size of character variable is. So this is, I'm going to write size of character and L. That's fine because size of character is not a problem, it is of 1 byte. I'm just going to build and run. It is going to say size of character is of 1 byte. That's fine. Now here if I'm going to write size of short character, do we have short character? No, we don't have short character. Even if I'm writing short character, you can see it is going to give us an error. So it is saying there's an error, and this error is saying that error long or short specified with character of type name. Okay, so here we do not have long character and we do not have short character. We only have character, we cannot have short character or long character. Okay, that's fine, that's understandable because character is only representing some symbols and those symbols are ASCII values, and because we only require 256 values in case of this C++ programming language, so we don't need it anymore. Okay, that's fine, that's good, fine. Now instead of this I'm going to write float variable, size of a float variable. So size of float, that's understandable because we know what is the size of float. Size of float is of 4 bytes. I'm going to build and run. Now you can see size of float is of 4 bytes. There is no issues, correct? Now what if we want to see, do we have long float? Do we have long float? Let us try to say long float. Now this long float does not exist. Why it does not exist? Because float variable is correct on already of type 4 bytes, but if we try to increase long float, then maybe we want to increase it to 8 bytes. But for the 8 bytes, they already exist a data type which is a double. Okay, so I'm going to write build and run. So again it is going to give an error. So it is saying the long invalid for type name. So here the long, we cannot use long for the float variable, correct? So obviously if we cannot use long, then we cannot use long float obviously, and as well as we don't have a short float. In the same way, if we have a double as a data type, double variable, now the size of double is of 8 byte. We know this one, and I'm just going to write build and run. Now here it is saying size of double is of 8 bytes. Can we have long double? Can we have long double? Now this is interesting here. Can we have long double? And yes, we use long double. Let us try to see, do we have long double? So I'm going to build and run, and it is perfectly running, but now this time the size is saying long double variable is of 16 bytes. But keep in mind that when I'm saying long double variable, the size of long double variable is not actually 16 byte, it is dependent on system to system, because I executed this long double on a different compiler and I got the size of long double as 12 bytes, and here with the help of CodeBlocks GCC I'm getting the size of long double as 16 bytes. So long double does exist, but for the long double the size of the long double variable is not fixed. You can get as 12 byte as a size of long double variable, as well as you can get a 16 byte as a size of long double variable. I hope this is clear. Now if we have long double, can we have long double? Can we have long double? Now this long double does not exist. If I am executing build and run, now try to see here, it is showing an error. It is saying long invalid for the type name. That means long double variable does not exist at all. Okay, now if we have boolean variable, and boolean is represented by bool. Now this bool is actually of it is only storing two values, either it is true or it is false. So if I'm going to execute this one, now it is saying the size of boolean variable is 1. but this is not in bytes, this is in bits. So size of boolean variable is in bits, this is in bits. Okay, so it is only of 1 bit, because it only have to store a value which is true, or it only have to store a value which is false. Now if we have signed int, unsigned int, signed character, unsigned character, their values are, the size is always the same. The only thing is we are just eliminating the negative values for characters which are signed and unsigned. Okay, the same way for integers which are signed integers as well as for the unsigned integers. Okay, now we discussed some of these data variables, and these are the only data variables which we'll be using for our program, for our purposes. And I think this is enough, because still there are a lot of things you can make out of this one. For example, we can have unsigned long integer, we can have signed long integer, we can have unsigned short integer, we can have signed short integer. So all the dependencies we are just eliminating this negative numbers. For example, if you just talk about integers, then integers further it can be either it can be integer, or you can use short int, or you can use long int, or you can use long int. Okay, so we got four varieties of integer: short integer, short int, long int, and long int. Size of integer is 4 bytes, size of short int is of 2 bytes, size of long int is of 4 bytes, and size of long int is of 8 bytes, right? And again, all these can be of two types. Number one, they can be of signed as well as they can be unsigned. This is a further of two types: signed and unsigned, signed and unsigned, signed and unsigned. And what is the range of the signed integer? For signed integer, it's always the minimum value will always be 2 raised to power minus of 2 raised to power n minus 1 to maximum plus of 2 raised to power n minus 1 minus 1. But for unsigned integer, the minimum value will be 0 to maximum value 2 raised to power n minus 1. Okay, this is valid in all these cases where n is a number of bits. For example, the first case, the integer is of 4 bytes. 4 bytes means there are 32 bits. So the minimum value will be 2 raised to power 31 minus, or maximum value will be plus 2 raised to power 31 minus 1. Okay, but what if we discuss about there's something called a short int? Now for the short int, the minimum value will be for the signed short int, the minimum value will be minus 2 raised to power 15 to maximum value plus 2 raised to power 15 minus 1. And this is the value which we generally remember, or which is generally given in the books. So it is minus 32768 to plus 32767. So the problem is people do not understand how you got these values, and they just try to cram these values, but they do not know the basics or logic behind how you are getting these kind of values. So this is because we are using 2's complement number, that is why it is the range is like this. Okay, in the same way we have long integer. You can find what is the minimum value for long integer, signed long integer or unsigned long integer. In the same way, what is the minimum value and maximum value for the signed and unsigned long integer. So these are the data types which we will be using for our purposes in most of the cases. So if there's any other data which we'll be using more frequently, then I'll tell you about it. Okay, so this is the basics for the programming language, which is C++, the data types. Apart of this, we can some of these basics are actually, they are also valid for the C programming language, because nowadays even if you are executing the latest version of C programming language, the size of integer for the C programming language is now 4 bytes. Initially, when you execute the the size of integer in Turbo C++, you will find the size of integer as 2 bytes for C language. But if you are executing the C language or C program in GCC compiler, or you're executing in code blocks or dev C++ or any other modern compiler, which are even some of the compilers which are available online. Now in those cases you'll find the size of integer is of 4 bytes for C language. Okay, so you can say size of integer is not fixed. It also depends on compiler to compiler. Okay, so all these concepts, whatever we have seen here for C++ language, all these sizes are exactly the same sizes are valid for C language also, and the same notations and the same range is valid for C language. So if you are going to execute them in this code blocks as a compiler. Okay, so I hope this is clear now. Let us move on to the next section now.